Hi, good afternoon. My name is Arjan Ramskamp. This is Eli G. Minder. This is 50% of our group. I wish I had a good excuse for you, but I don't, so it's 50%. So. We're going to run you through a little bit of context first about Bangladesh and why we were there, go through some of the results, and since we've boiled down an hour-long presentation to now about 10 minutes, we'll try to get to the essence of it. So this is the context for Bangladesh, 144,000 square kilometers, size of the state of New York. Population-wise, that means take this room, stuff another 8 times as many people in there, and that's sort of the feeling when you walk around in Bangladesh. World largest delta, floodplains about 80%, and then it's a major delta comprised of 3 major rivers, the Ganges, the Brahmaputra, and the Meghna Delta. Himalayas in the north, Bay of Bengal in the south, makes for an interesting environmental setting, that's to say the least. We were particularly interested in flooding. There's a range of issues that you can address when you go to Bangladesh, and somehow they all interplay. We were specifically interested in flooding. It's not something you can easily come up with a blueprint solution for, simply because flooding is not necessarily a negative thing. So there's a lot of alluvial deposits that come out of it, soil moisture, irrigation in the winter. The Bangladeshis actually use the floodplains for fishing during the seasons when there's inundation. So there's a range of issues that you need to take into consideration when you start addressing flooding as a potential problem. Of course, the negative things of flooding are a little bit easier to pinpoint. Casualties, direct damage to infrastructure and housing. Indirect, people are literally without income for anywhere from 1 up to 2 months. Health-related impacts, inundation leads to waterborne diseases. And there's a lot of environmental implications, which range from saline intrusion in the coastal area to soil erosion and a degradation of coastal defenses. 5 types of flooding. We can go into this a lot, but we're not going to. We're specifically interested in river flooding and tidal flooding because those coincided with the areas where we actually did our interviews. So this gave us a chance to compare desk research to field data and see if we can somehow bring the social together with the scientific. So this is the key question. Are we basically accepting flooding as something that we're just going to have to live with? And are we only using minimal infrastructure to address the problem, which is sort of the laissez-faire approach? Or are we looking at a more heavy-handed, I don't want to say Western approach, but some kind of technological innovation, some kind of engineering project, the heavy-handed approach to address flooding as an issue? It won't be a surprise that we're going to end up somewhere in the middle of these both extremes. Water management, there was a major flood in 1988. There was actually a number of major floods between now and 2000, or between, let's say, the mid-80s and 2000. 88 is actually the silver lining, for as far as you can talk about silver lining with flooding, is that it created a flood action plan, which means that flooding officially ended up on international and national agendas. The original plan was very heavily criticized, and I have to say that original plan was originated by the French and the Dutch, which are my countrymen. So apparently if you're willing to pay a Dutchman, he's going to build you an embankment. Apparently that wasn't the way to go. So that plan got rejected. And water management was readdressed. Problems that we wanted to isolate as a group was climate change. When we talk about climate change, we're specifically interested in sea level rise, which is not just about rising water, but it's also about retention of sedimentation in the floodplains. It's about actual where's the water stored. If there's high temperature, that means melting ice sheets, which raises the level of the water. Natural and accelerated compaction rates, especially accelerated compaction rates, are a major issue. We are basically overexploiting the groundwater, which is creating pockets, which is causing subsidence. So finally, we are interested in sort of the overall sea level, the way it compares. Finally, we're obviously aware of the fact that Bangladesh, in top of all the challenges they have, are also located on top of a tectonic fault line, which creates some seismic activity and whole other set of issues. So we didn't solve all of them in 3 months, but we like to say that we did something meaningful. So I'll just keep taking this and then give it to you. Yeah, sounds good. Okay. This is our research objective. We're trying to create a local perspective to a global problem. So we wanted to make sure that from a Western perspective, we were just not pushing a number of engineering ideas. We wanted to talk to the people on the ground and actually ask them what it is that you really need. If you were in charge, what would you do? So it creates a very interesting range of questions and answers. And obviously with those answers, we were trying to match them up with the scientific desk data. Turns out that we have a lot of great ideas. not all of them are as simple as the Bangladeshi actually need them to be. So, and that's of course the social scientific debate which comes through. These are the locations. We did about 20 interviews based on the time allotted. That was about all we could do. One in Sirishganj, which is probably about 3-4 hours west of Dhaka, and which is close to the major river. So that would be a good example for us for areas subject to river flooding. And then there's the Sundarbans, which is in the southwest portion in near the town of Mangla, and that's mostly subject to tidal flooding. So those are 2 locations. These are interview questions before we left. Where did you go? Do you remember the last flooding event? Did you come back? What kind of technology do you use? Which is the question we were kind of banking on to see if we can use that as a backup to us introducing a type of technology. Didn't quite work out that way, but we'll get to that. And also, if you were in charge, what would you ask for? And as we were going through the interviews, we asked people if they thought that flooding was getting better or worse. Lack of background knowledge, lack of sort of time to maybe do trial runs on these interview questions leaves some sort of interpretation issues. Like if flooding is getting better or worse, we noticed that a lot of people were basically saying, well, we had a major flood 3 years ago, we haven't had a major flood since then, ergo flooding is getting better. So it makes for some interpretation issues. We're now 3/4 of flood. There you go, that's Pat. So these are some of the interview results that we asked for. So on the left, you see the technology question, where we were thinking about things like floating agriculture, high yield seeds. We're thinking about solar power, some kind of technology that we could infuse into the entire sort of flooding discussion. As it turns out, the most technology that we got back was most people have access to a cell phone, which for them is considered a technology question, which makes me believe that we probably should have narrowed technology as a sort of a concept down a little bit. And self-installed tube wells. Those were the 2 things that people were most concerned about and had access to. So that question didn't really come back from us from the field to any kind of recommendations that we could use to apply towards technologies that we have available. If you were in charge, this was kind of eye-opening for us. Nobody was asking us to be moved to higher grounds. Nobody was asking us to eradicate flooding altogether. People basically said, I like where I live. I want to stay here. Please elevate the ground. All right, fair enough. They also said, we need an advanced warning system, which right now some people were giving us indication, especially in the tidal area, that during the last major flood, they had literally 1 hour of advance notice. Somebody came up to the house and said, there's a major flood coming, grab your stuff, go. So now you're running to a local shelter 2 miles away, trying to get there in an hour, and then we found out that these shelters were actually built to accommodate 15,000 people in 5 villages with a capacity shelter of 500 for a cyclone shelter. So that was the 3rd question they asked for. They said we need more accessible and larger cyclone shelters. So all of these are very practical. All of these are, we don't want to go anywhere. Don't move us. Just help us live where we are and make it work. So these are some of the other interview observations. Most of the people went within, let's say, a 2-mile radius when they had to go somewhere. Everybody came back. And with regards to the question that fell off the screen there, in Sirishganj, area subject to river flooding, so everybody said it was getting better because we hadn't had a major flood in 3 years. And in the tidal area, where there's actually more consistent flooding throughout every season, they were actually telling us that they thought things were getting worse. So we kind of took off that, and then we started matching some of our water data. I'm doing a lot of talking here, and I'm stalling because that's James, and he's going to talk about water data. Yay!
We just talked about surveys and how there is a differential effect in tidal versus river gauges. So what you see on the PowerPoint right now is actually a time sequence plot for a river gauge in Bangladesh. You can see this, essentially it's just depth of the river over time, and this is about 7 years of data. You can see within the data set a very strong seasonal trend. Essentially goes from somewhere around 7 meters of depth to 14 in the rainy or flooded season. And essentially what we tried to do is look at what we found in the survey data. So do we actually see the effect that that was observed in the surveys, which is that there is no effect of increased flooding in river areas. So here we have the actual model that we use to evaluate this. This is a seasonal ARIMA model, which stands for Seasonal Autoregressive Integrated Moving Average Model. There's not a test on that. And then, so essentially all it does is predict the value of river depth based on a couple of the data points ahead of it, as well as a seasonal component of the model as well. And you can see there's actually a very good fit. And also you can see that there's a forecasted part at the very end there. So essentially what we found here is that the trend component of this model was not statistically significant, meaning that what we saw in the surveys, the result that there is no statistically significant increase in flooding, was confirmed by our model results. So we did the same exact thing for tidal areas as well. And as I said before, we found in the tidal areas that people said flooding was getting much worse. So same exact data set, but you can see here, since it's tidal, the actual difference in depth is not as big, because essentially you're connected to the ocean and you're not varying as much in a seasonal thing. But you can still see over 7 years, there is this seasonal trend and there is a lot of noise, or at least more so in the river. And the reason for that is, of course, the tidal effects that happen in this area of Bangladesh. The fact that it's not just water coming down and during the rainy season being more, there's also a lot of other oscillations going on in the data set. So here's our fitted model yet again, and you can see, as I said, much noisier and not quite as clear. But we did look at several of these stations within this area. So I think altogether, here we have them here, it's about somewhere in the area of, I think it was 11 stations. And you can see our results here. So this is for tidal stations in Bangladesh around where we took the survey data. And if you look essentially on the far column is what we really want to be focused on. A lot of them didn't produce any statistically significant trend, but the two that did, which are right here with the asterisk right next to them, so about 4.9 and 5.02 millimeters per year increase in flooding, we did find a statistically significant trend, and one which is actually on the order of magnitude of what is observed in data sets that have looked at increases in flooding or increases in sea level. A recent paper we looked at estimates it at about 3.2 millimeters per year. So we think that the 5 millimeters around there that we find in the tidal areas of Bangladesh is actually a result of both sea level rise as well as tectonic subsidence. But obviously, further analysis has to happen to really confirm that. So yeah, so those are the two that we're looking at. And this is just a summary of exactly what I just said. We find no statistically significant trend in the river areas, but a statistically significant one in the tidal areas of about 5 millimeters per year, which implies a sea level rise in the tidal regions of Bangladesh.
Thanks, James. So how are we doing on time?
We're doing okay. We actually started a little early, so we're fine.
Okay, so hi, I'm Eli. I'm a dual major archaeology and sustainable development. My job, hopefully in the next 3 or 4 minutes, is to explain how we took the social science data that Arjan explained and combined it with the remote sensing data and the tidal data in order to come up with our recommendations. So hopefully we'll be able to accomplish that. Okay, so essentially, there's a quote from attributed to Charles de Gaulle that in my lifetime of all of the problems I've ever heard, none of them has ever been solved. And that's sort of the attitude that we take to our research, that you have natural hazards throughout the world, but until you put communities in sensitive ecological systems where they're subject to surprises, you tend to get disasters like flooding. So our approach is to look at these interactions between ecology and social systems and see how we can strengthen them in order to make those communities more resilient. So you can actually never solve an issue like flooding. There's never going to be any quick fix. You can't just, buy some embankments, install them, and never have it be an issue again, especially in a resource-scarce environment like rural Bangladesh. The best you can do is to look at the ways that people have been coping with floods for the last few centuries and try to enhance their ability to cope with those stressors and adapt in the future. And this requires a sophisticated management approach that takes into account dynamics on multiple different scales. And in this chart, you can see that there's a pretty complex array of dynamics systems to look at. You have the ecological domain, which in this chart is represented as biophysical water systems. Basically, Bangladesh is one giant drainage basin. And these are people that have been living with floods and living in a very close ecological symbiosis for a very long time. So they've learned how to live with rivers, learned how to live with the floods, and they, as Arjan intimated a few minutes ago, depend on floods for their livelihood because the floods bring soil that they need for subsistence agriculture, etc. A lot of the things that we saw when we were in Bangladesh fall under the category of traditional flood control projects. We saw a lot of embankments. I'll just skip to the next slide because there's some actually great pictures there. Here on the bottom we see an embankment in Sirajganj in the north of the country, if you remember from that map that we saw a couple minutes ago. But the problem is that once these systems are installed, there's a tendency for them to be neglected, and so oftentimes they simply fail. In the south of the country, when we were interviewing people, we heard a lot of anecdotes about communities having to actually breach flood walls in order to keep the floodwaters out of their communities, which tends to be unfortunate for the people living downriver, but this is symptomatic of a management approach that tends to be a little bit too heavy-handed and doesn't really take into account the mechanisms that people already have to cope with floods. And just briefly, there has also been a pretty significant movement towards building these flood and cyclone shelters, which are expensive. They're also very useful as multipurpose buildings. But the thrust of our argument is that this is only part of the solution. The other part is to look at soft infrastructure institutions that tend to strengthen people's abilities to recover from floods and to develop sustainably. A couple examples that we're going to be looking at in the next 6 seconds or so are social capital, that is community ties. Thank you. 3 minutes. I'm being told I have 3 minutes left. Two main issues. One is social capital, that is the ability for people to rely on connections in other communities and also both horizontal and vertical relationships across space and between levels of social organization that enable people to recover from floods. That'll be explained a lot better in the next slide. Okay, so this is sort of a visualization. It's not very statistically accurate because this is data taken from a couple different survey questions. However, it shows that there is a barrier, there are a few barriers to people protecting themselves from floods that tend to destroy both financial resources on which communities rely, their farmlands, their houses. Cattle tend to get washed away, and the other problem is that because Bangladesh is a large alluvial floodplain, in heavy floods, is a tendency for land to get washed away. And so people have to relocate, they have to regroup, they have to sell off capital in order to be able to make ends meet, and these are people with very scarce resources. So a lot of people honestly either don't have the means to prepare for floods or don't really know what measures to take. Two basic types of preventative measures that are taken are having to do with adapting your community to the risk of floods. If you have the financial resources, a lot of households put their houses on top of elevated foundations, which is great if you have the means to do that, but a lot of people don't. On the flip side, in order to be able to recover from a flood, you need access to certain things. You need access to microcredit, you need a strong social network, you need people, neighbors, friends in other communities on which you can rely while you're recovering from devastation brought on by a flood. And so our aim in our recommendations, which you'll see in a moment, is to come up with ways to strengthen those kinds of ties and also the sharing of information that facilitates better resilience. Okay, so this is our main recommendation, which is to, as Arjan intimated, the telecommunications infrastructure in Bangladesh is surprisingly robust for such a poor country. There's about 86.5 million mobile phone subscriptions. That's for every man, woman, and child, which comes to about one cell phone for every 2 people. And that's also in the rural communities. There wasn't a single village that we visited where they didn't have access to at least one mobile phone. Despite that, a lot of the people that we interviewed mentioned that they didn't really receive any kind of formal warning, or if they did, it was usually from an NGO, or if it was from a friend down the road. There's no way for them to prepare adequately for imminent flood danger because the infrastructure just doesn't exist right now. So we are recommending a mobile phone hazard alert system that would take available data and leverage it in a way that makes it accessible and easy to interpret for rural Bangladeshis by giving them access to the amount of information, allowing them access to the information on what kinds of resources are available to them. So basically, you would get a text alert on your cell phone that would tell you that there's a flood coming, what type of flood it is, and then some brief information about where your closest shelter or elevated piece of land is in order to create a more efficient way to protect people from floods. Thank you. Other 2 ideas that we won't have time to go into today are creating better public awareness through community outreach campaigns, creating flood education and awareness in elementary schools, a lot like emergency preparedness programs that you have in the United States, especially in places like California that are prone to a lot of natural disasters. And also creating a sense of local responsibility in order to enhance the involvement of people in their local flood control infrastructure. Creating a sense of shared responsibility also creates employment at the local level and helps to alleviate the problem of poorly maintained infrastructure, which is a big issue for developing countries. In conclusion, we actually think that even though we only surveyed about 20 households, combining that limited slice of data with remote sensing information is problematic in this case. Rather than look at that as a limitation, we think that there's actually a lot of opportunity to combine social science data with instrumental data in order to create more appropriate recommendations for climate change and disaster mitigation, and also, more importantly, ones that take into account the aspirations and capacities of the local people. That's all I have. Thank you.